Any query related to the last topic that we have discussed, object, classes, and anonymous object creation? Okay, thank you, Induja, for your input. And heap memory allocation and static, non-static. So all those things is clear. So thank you so much for your input, Justin. Yesterday, when I was taking the session, I made a statement in which I was saying that when any unreference variable, whenever any unreference, so unreferenced variable is eligible for garbage collector. Can you hear me? Because yes, because I can see one message from the internet provider that my internet is not working. Now, can you hear me? Hello. Now, okay, fine. So, okay, every time if you're not able to hear my voice, just let me know. Fine. So I'll open first that statement over here that I auto memory management. Look at here. Unreferenced variable are eligible for garbage collector. Actually, I want to make correction over here. Unreferenced objects, because objects are unreferenced, because every object, whenever you create any object, every object has a reference. So whenever you assign null to any reference, that object become unreferenced. So this is statement, when I was seeing today, then I realized that this statement is wrong. I was written yesterday, so I just want to make clear. I hope this statement is clear to everyone. Not bad. For example, just one more time. This line will create an object. Okay. So when you assign this reference to the null, this object will become unreferenced. It will not have any reference to point. So in that case, this object will be eligible for the garbage collector. So any unreferenced object is eligible for the garbage collector, not unreferenced variable. So make a correction in your note also. Unreferenced objects are eligible for the garbage collector. Now, I will start this session, but today we'll see some more things. Like, first of all, we'll see that how to take inputs from the user. So today's topic is take input from the user. So there are so many mechanisms and methods which are available to take the user's input to the program if you want. So Java provides many number of classes by which you can perform this operation. But the most frequently used in the nowadays a class which is called a scanner class. So we use a scanner class to take users input, and this class is already available in your JDK. You just need to create an object of this class, and after that you will be able to take the user's input. Okay, so few things before creating the object of this class. Few points that you need to remember every time, that if you want to create any object of predefined classes in your source code, you need to import them first of all. If you want to create any object of predefined classes, either that class is provided by the Java, or you have created your own classes. So if you need to create object of that class, first of all you need to import. So first of all, import the required class first of all if you need to create an object. And if any class belongs to the package that is called java.lang package, if any class belongs to the package java.lang package, it is a package in a predefined package by the Java, in which the Java has so many classes, predefined classes that you can use in your code. So if you want to create any class in your code that belongs to the package java.lang, import statement is not required. So if any class belongs to the package java.lang, import statement is not required. I hope this is clear. And since we want to use the scanner class in our code, and this class belongs to, scanner class is in java.util package. So scanner class is in java.util package. So it means we have to import this class before we want to use it. So let's create an object of the scanner class, and after that we'll take the user's input. So first of all, write the import statement, import java.util.scanner, first thing. And as we know, if we want to create the object of any class, we write first of all the class name. So we will write first of all scanner with a reference. For example, the SC is the reference of this class we are going to create the object. With the new, we call the scanner, and here we will pass a source, that is system.in. Why we are passing system.in, I will explain in detail when we will learn the IO package. But just remember this point, that system.in represents your system's standard input device. So we want to take the input, we want to take or scan the input from the system's standard input device, and every system's standard input device is keyboard. So this represents the keyboard of your system. So whenever the scanner object will start to scan the input from the user, it will scan from the keyboard. And a scanner class has so many methods that you can use to take the user's input. For example, if you want to take int type value, then we will use a method that is int next int. This is the method that we will use to take the integer type of the value from the user. So how we will write? So I'll make first one statement that user will understand that which type of the value you want to take. So println or print, we can write, I want to enter a number from a user in which a variable integer a sc dot next int. Now check that the input value is stored into the variable a or not. So here I will write entered value is plus a. So let's compile and execute this code. Here we will write java c. My source code name is my class.java. So if is there any error, then it will show, otherwise your command prompt will be available. Java and your bytecode. So enter a number. So I'm entering a value that is 12. So entered value is 12. So this is the way that you can take the user's input of any type. So for int type, we have a method that is nextInt. Similarly, if you want to take the value as a byte, so for byte type, the method is called nextByte. Okay. For short type, method is here next short. Now you can identify very easily that which type of the method you will use for a specific type. For example, if you want to take the type int, then the method is next and int. For the byte, this is next byte. For the short, next short. Similarly, if you want to take float type, that method will be next float. For the double, next double. If you want to take the value as Boolean, so you will write next Boolean. Clear? And for a string, if you want to take the value as a string from the user, the method, there are two methods. One is called next and second one is called next line. Next and next line. So what is a difference between next and next line? So when you use a next, it will take only the value, only those string which doesn't contain the spaces. Okay, and if you want that the value or the string should contain the space whenever the user provide the input, then you will use next line. So here I'm going to provide one message to the user, system.out.println or print enter name, and I will store into the string. So a string name is equal sc dot next, and again just copy and paste. Entered name is plus name. So come to the compilation and execution. Enter the number, so 12. Enter the name, so I'm putting the name Alex. So enter name is Alex. I'm going to execute one more time to make clear that next will not take any string that contains the space Alex Chan. So as you can see, only one value is going to be stored into the name variable, the name string type variable, because we are using the next method. So if you want to take a string as it should contain the spaces, so in place of next method, you will use next line. So this is the way that you can take the user's input by using a scanner class. So make sure that if you are using any class in your code that doesn't belong to a java.lang package, you need to first of all import. And after that, you will create the object of that class. And by the help of the methods, you can perform the operation. So I hope scanner class and the user's input is clear to everyone. Fine. So whenever you need any input, use it. Now come to the topic. Let me open the slide. So yesterday we have already discussed these things. So first topic we'll discuss today, that is constructor. So what is constructor, and what are the rules to create the constructor? It is very simple. Constructor is a section of code that executes after allocation of an object. Okay, we'll see with the example that what does it mean, that constructor is a section of code that execute after allocation of an object. What is the purpose of the constructor? Okay, it's still not coming. Oh. Yes, now it gets fine, but still you are getting breaking. Okay. So now what is the purpose to create a constructor in your code? So every time whenever I ask to the student that what is the purpose of the constructor, then student says that to create an object. So just make sure that constructor is used to initialize the data fields of the object. Okay, creation of object is another thing. The main purpose of the constructor is to initialize the data field or instance members of the object with some dynamic calculated value. This is the purpose of the constructor. And how do we declare that? The constructor follows the following naming convention. One is, its name will be same as of its class, and it will not have any return type. So if you want to create any constructor in your class, you need to follow this rule. So here if I want to create constructor of this class in our code, I will write my class because the class name is my class. So the constructor name will be same as the class. So this will be called constructor. This is called constructor. Let's see that this will execute it or not. So system.out.println. So I'm writing only one statement. I'm constructor. This one. Now let's create an object of this class by using this constructor, my class, and this one with the help of new. Come to execution. Java C, then Java and my class. As you can see, your constructor gets executed. So this is not the purpose of the constructor that you should that we should write any statement. The main purpose is to initialize the data members. And this constructor is called non-parameterized constructor, or we can say the default constructor. Actually, we should say this is a non-parameterized constructor because it doesn't have any parameter. So non-parameterized constructor. Or you can create a constructor that can accept a parameter. Parameter means you can pass any value. Now, since we have a constructor which takes a parameter of type integer a, so when you create any object, this is called parameterized. So whenever you create an object and you are calling a constructor, you need to pass the int type of value. Otherwise, you will get error. Now look at the compilation. So you can see here constructor my class in the class cannot be applied to a given type because my class ob new class, this is we are calling required integer argument and found no argument. So actual and formal argument list different in length. That's why we are getting error. So you need to pass a value. After that, when you compile it, the error has gone. So this is called a constructor that is parameterized. And when you create any parameterized constructor in your code, whenever you create any object, you need to pass the construct parameters. So as many as number of parameters you have declared, you need to pass over here. What is the purpose of the constructor? To initialize the data members with some dynamic value. What does it mean? Suppose we have an instance variable that is integer a, and we are not initialized with any value. So now, when we create any object of this class, we want that this a should be initialized at that time with some dynamic value for every object. So we will write like this dot a is equal a. So now, when this object will get created, 12 will be assigned to this variable. And as we know that with the one class definition, we can create as many as number of objects. So ob1 is equal new my class, and we want that this object's a should be 10. So you can pass another value for this instance variable. So every time whenever you create an object with the help of this constructor, it will assign or initialize the instance field with some dynamic value. For this object, it is 12. For this object, it is 10. So I hope this is clear that what is the purpose of constructor. Clear? Okay. One more thing related to the constructor that is very important to know. When you create any class definition, for example, this is your class definition, and I'm not writing any constructor in this definition. As you can see, there is no constructor definition in your source code, but listen this point. But when you compile your code, and the compiler see that there is no constructor in your class definition, by default, a default constructor is added to your bytecode. A default constructor is added to your bytecode. Okay, to understand this, that in bytecode, the default constructor is added or not. So look at this compilation and execution. Look at the code first. Only the class definition, main method. I'm creating an object and I'm going to compile it. Now my code has been compiled successfully, and after that we get this bytecode, that is my class. Where is that? Sorry, this one, my class. Now let's see the definition of this my class. So when you will open it, it will show you some symbols. So you won't be able to read this code. So we will use a command that is called javap. Javap is actually called deassembler or a reflector. It is called deassembler or reflector, javap. So by javap, you can see the class structure or class definition. So javap, and the class name is my class. So I'm going to reflect it. So as you can see, this class comes from myclass.java. As we know that our source code file name was myclass.java. So javap will tell you that what will be the source code file name. So source code file name is myclass.java, and this is the definition actually generated after compilation. And here you can see one default constructor is added to your class definition. Got it? So when this default constructor will be added by your compiler or after compilation process, when you are not declared or defined any constructor in your source code. If you have defined a constructor in your source code, then that constructor will be added to your bytecode. Got it? Because this point is very important, because when we will learn the inheritance, so this concept will come one more time. So that's why I'm telling you that if you don't have any constructor in your source code, a default constructor will be added. And if you have the constructor in your source code, then that constructor will be added to your bytecode after compilation. Clear? To understand, one more time, I will write the same integer a here, and I'm not writing any statement into it. I will just compile and deassemble it. Okay, because I don't have a default constructor, so I need to pass a variable value. Now compile it and deassemble it. As you can see, compiled from myclass.java. Fine. This is the definition of class after compilation. So this is the bytecode. So as you can see here, my class of one int type value accepted. So there is no default constructor. So I hope this is clear to all of you. Fine. Okay, good. Now come to the next part. So this is the concept of polymorphism. As we know, Java is an object-oriented programming language, and there are so many. In object-oriented programming, there are four major concepts. That is abstraction, polymorphism, inheritance, and encapsulation. So polymorphism is one of the feature of object-oriented programming. So before going to this topic, I want to explain some more things that will increase your coding efficiency. I will ask some question and just tell me that you can do this or not. I'm just going to ask some question and just tell me that are you able to do this by your own or not? Okay. Suppose if I tell you the name of the class, okay, and I tell you the method signature, I will tell you the class name, I will tell you the method signature. Can you call that method? Just tell me. Okay. So if I tell you the name of the class and the method signature that belongs to that class, so can you call that method? Okay, what is method signature? Okay, method signature means the return type, or you can say method prototype. Return type, method name, and argument list. Now this is called. Okay. As you know, every method has some return type. If it doesn't return any value, then that will be void. The name of the method maybe just we have earlier used, that is next int and int, next float and next, and there are so many methods. So if I tell you the class name and the method signature, so fine. So you all are able to call this method. For example, if I say the class name is test, okay, understand it. The class name is test, and method name and the method signature, if I say method signature is void show. Okay, so you need to call this method of this class. How will you call it? You will definitely, first of all, we will create an object of this test. So this is the way we will create, we will call this ob is equal new and then test. I'm writing correct? Am I writing correct? And ob dot show, isn't it? I hope this statement is clear, because the class name is test and the method signature says that void and show. So you, first of all, you will create an object and after that you will call the method. Another method is static void display. Static void display. Oh, sorry, display. This one. This is one method. Another method is static void display. So is it required to create an object to call display? No, as we know that we can call test dot display. Fine, because the static member can be called with the class name directly, so it is not required. I hope this statement is also clear. Fine. So there are so many classes, there are so many interfaces in Java. If you will count, then there are number of classes, more than 10,000 or more than 10,000 classes, if you will call it. So how will you remember all the methods and all the signature every time? So this is really not possible to a person. So what we do in that case, uh, we use this javap. javap is called deassembler and reflector to see the definition of the classes, either that is in build class or user defined class. As we have already seen, javap we have already used to see the class definition of the my class. In the same way, if we want to see the existing class definition, we can use the javap. So as we have already used scanner class, so look at the scanner class definition: java.util.scanner, java.util.scanner. And when you will hit the enter, you will see the definition of this class: javap, java.util.scanner. And as you can find so many things over here, so how will you find that which one is method and which one is a method and which one is your constructor? So you can see any class definition by using javap, and this is very handy tool provided by the Java for the development, because it is not necessary and it is not required that every time you have remember all the methods. Maybe if you forget the method signature and you are try to use it, then you will. So I don't know why. Okay, tell me, screen is visible? Okay, that's still not visible to you, because I got a message that your screen sharing is interrupted. Okay, now it is visible. So as you can see, this is the scanner class, and if you found any name that is similar to your class name, as we have already learned, that will be your constructor. So you can find these are the similar to the class name. So this is called constructor. So how many ways to create an object of the scanner class? You can count it: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 constructor. Uh, Still not coming voice, Hinduja? Okay, okay, fine. Okay, so I was saying that this is the Java P. You can apply to any class. I'm applying on the scanner class because we have already seen this earlier. So if you find any name that's similar to the class name, we know that member will be constructor. So here you can find scanner over here, scanner, scanner. It means these are the constructor of this class. So you can initialize the members of the class by using any one of them. And so there are 10, you can, if you'll count it, there are 10 scanner constructor into the scanner class definition. And here public final class java.util.scanner implements this. And so there are so many things, but I'm coming to a method that we have already used, that is next. We have already seen that next method we use to take the user's input as a string. So that you can see the return type of the next is a string. Okay, and we have already seen that next line we can also use to take the string input. This is the return type, this is the signature of the method. The next byte, you can see next short, next int. So all the things you can see by applying Java P. Fine. So this is the way that you can use and see the methods and the signature of the methods of the classes. And after that, you will decide whether we have to create an object to call it, or we can call direct that method. If that method consists any static, then that method will be called directly. And if that doesn't consist any static in signature, you need to call with the help of object. So just Java P is clear now, because after that I will hint you that to perform any operation you can use this class, and this class will be available in the particular package, and after that you will explore by yourself. This is the way that we learn the Java. Fine. So this is called Java P. Okay. So before moving to the next topic, that is polymorphism, I want an input from your side that all the concept that we have learned, do you have any doubt? Because that polymorphism is a new topic. So before going to the that topic, I want the input from your side. And if you have any doubt, then you can put your queries. Then we'll move to the next topic. Yes. No query. Good. 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 Okay. Fine, Meng. And everyone just use the Java P. It's my recommendation to every person. If you will aware the Java P, then you will do a lot of things. Now come to the polymorphism. First thing I want to mention over here, since polymorphism is a concept of object-oriented programming, and as we know, object consists of three things that we have already discussed. One is ID, unique identity. Second one is called state, and third one is called the behavior. Okay, as we have already discussed this thing, let me show you. So these three attributes of the object: unique identity, state, and behavior. And in programming, for the identity, what we use? We use a reference variable. So we create reference variables. Okay. So in programming, for identity, we use references by which we identify the object. For the state, we create instance variable. I hope this is also now clear. Instance variable. Instance variable. And for behavior, we use method. For the behavior, we use the methods. Fine. Now, when we talk about polymorphism is related to the behavior of the object. It means the polymorphism concept will be applied only on the methods. Don't try to use or apply on the variables. So polymorphic behavior is only applicable on the methods, not on the variables. I hope this statement is clear to all of you. Now come to point. Polymorphism means if any object has a behavior and if that object shows that behavior in different way, a single behavior in a different way, that is called polymorphism. For example, for the human being, if we take the example, a human can talk, but as you can see, if a human can talk, so human can talk in a different way with the different people. For example, if you talk with your parents, then you talk in the different way. When you talk with your friends, then you talk in the different way. But the behavior remains same. That is, you are talking to each other. But as you talk to your parents, you won't talk with your friend, or you will not talk with your teacher or any other person. So this is how the polymorphism exists, or polymorphism is applicable. So this is the behavior of human. So that's why the polymorphism means an ability to access one or more behavior methods by using a single interface. Single interface means the name will be always remain same, and it will be of two types. One is called a compile type in terms of the programming, compile time polymorphism, and second one is called the runtime polymorphism. And to implement the compile time polymorphism in coding, we use method and constructor overloading. What is mean by overloading? We'll see with the example. We use method and constructor overloading to achieve compile time polymorphism. And method overriding is used to achieve runtime polymorphism. So this is the way that we achieve the polymorphism: method and constructor overloading and method overriding. So what is a method overloading and method overriding? Now see this. Method overloading means defining multiple methods with the same name but having different parameter list. The method name will be remain same, but the parameter list will be changed. And how do we change the parameter? The first way to change the parameter is we create a new method. We create a new method definition with the same name having number of parameters different, or the types of the parameter is different, or we make the both different. And this point is very important. A return type doesn't play any role in method overloading. So a return type of the method, as we know that the signature of the method consists return type also. So return type doesn't play any role. So let's see an example of this method overloading. Come to the coding. This is the way. Now, if I create a method with the name of add, that can add two numbers, that is integer a is equal 10 and b is equal 20, like this: system dot out dot println and sum is equal plus a plus b. Okay, so this is the behavior of this class, that this class has a behavior which can perform the addition of two numbers and it will show the result. Now we want that it should add two variables that we will pass into it. So this is the way that we overload a method. As you can see, this method have no parameter and this is having two parameter list. So to overload a method, the requirement is to change the number of parameters. As you can see, there is 0 parameter and here is 2 parameter having the same name. So this is called the method overloading, and I'm going to write this one. Again, if I write int add, we can change the type also. So as you can see, there is integer and int. So if we make a change, like if we make a variable as float a and another one is int b, okay, so now this is also called, and since we have a return a plus b. Now let's make it as float, so this will make convenient to us. So now to call these methods, you need to first of all create an object. So we will create an object by this, and when you call any method, at the time of calling, the parameter matches with uh, the method, that method will be called. For example, if I write ob.add, so it will call this method. If I write ob.add and if I pass 1.2 comma 3, so this will call a method that matches with this parameter. And since this return a value of a float, so we can store into the float variable. And we can print it, the result of this returned value. Sum is equal, that is f. First of all, let's see is there any error or not. And okay, 1.2, okay, fine. By default, it is double. That's why. Yesterday we have seen that 1.2 is yes, Hinduja. Good, good. So now if I run it, so accordingly, it will call the method. So sum is equal 30 and sum is equal 4.2. So as we can see here, so this is called method overloading. In the same way, you can create more than one constructor in your class, and you can overload that constructor also. So this is by this way we can achieve compile time polymorphism. So here I'm going to create a constructor my class. So this is called non-parameterized. Now if I want to create a constructor that accepts some value, for example integer a and integer b, then we can create it. So this is the way that we can create more than one constructor. According to our requirement, we can overload the constructor. And at the time of object creation and member initialization, if you have the constructor that you define in your code, you can call as per your requirement. So this is clear. Method overloading and constructor overloading. Fine. Good. Good. Now, just remember this point for the method overloading. That method overloading will be only in same class. Okay, so there is no need to create any other class and any other thing to overload it, because we will create a same method with a different signature in the same class, and that is called overloading. And second type of polymorphism is called a runtime polymorphism, and to achieve it, we need to override the method. So for overriding, first of all, we have to understand the concept of inheritance, because if there is no inheritance, you cannot perform the method overriding. It means to override a method, the first requirement is there must be inheritance. Clear? There must be inheritance. So before going to the inheritance, I just need to explain few more things that is important, and it is called access modifiers. So do you know access modifiers? And how many access modifiers in Java? Fine, Meng, thanks. Justin and Hinduja, do you know access modifiers in Java? Okay, good. So a quick revision of that part. Okay. I'll delete some code that will help you to make clear it. Fine. So in Java, there are 3 access. Somewhere you will find access specifiers, or somewhere you will find access modifiers. So I will write access modifiers. Okay, and these are public protected and private. Okay, so there are three access modifiers that we write as public, protected, and private. Now tell me, if I write integer a, so what will be the access modifier of this a? What is the access modifier of this integer type of variable a? Justin says protected. Okay, fine. Hinduja says it is public. Okay, good. Yes, Meng. I'm waiting for your input. No, clear. Okay. So that's why. Just a quick recap. It will not take too much time to explain it. Actually, in Java, we write three access modifiers as public, protected, and private. And here is the condition. And if we don't write, if we don't write any access modifier, if you don't write any access modifier, then it is by default default. It is by default default. So in case of this declaration, the access modifier for integer a is default, and we don't write this default access modifier. By default it is default, so it has also accessibility level. So if we say in one line, so we can say that Java has three access modifiers to write, that is public, protected, and private, but it has 4 levels of the accessibility. Got it? 4 levels of the accessibility. What is mean by access modifiers? Actually, these things, public, protected, private, and default, sets the accessibility of the members of the class, that where you can access these members and which part of the code can access and how many distance it will be covered to access, that its visibility. Okay, so default. In case of class, in the case of class, why I have mentioned in the case of class, when we will go in the topic of interface, then you will understand this very carefully, but this clearly. But right now, just understand this: Java has 3 access modifiers to write, that is public, private, protected. But if you don't write any access modifier to members, then by default it is default, and default has also accessibility level. So it means there are 4 accessibility levels, and I'm going to write the accessibility in decreasing order. Okay, so I'm going to write the accessibility in decreasing order. That's which one has the more accessibility and which one has the less accessibility. So public having the maximum accessibility. If you declare any member as public, then that member will be accessed anywhere. After that, protected. It has less than public accessibility. Then comes default, and default we don't write. That's why I'm writing into bracket. we don't write into the code. And after that, private. So this accessibility level is clear, that public is maximum, then protected, it is in decreasing order from top to bottom. Fine. Where you can access the public member? So we can access the public member everywhere or anywhere you can access. This has the accessibility for everyone. For protected, okay, for protected, within, if you declare any member as protected, you can access that member within the same package. Okay, you can access that member within the same package, and if you want to access that member outside of the package, what is package we'll see in the detail, because package is the concept, and we'll see that how to put a class into the package. So within the same package and outside of the package by inheritance. Okay. Inheritance through the child. Okay, so if you have declared any member as protected, then that member will be accessed within the same package and outside of the package by inheritance through the child. If you have any member as default, then that member will be accessed only within the same package. Only within the same package. And if you declare any member as private, then that member will be accessed only within the same class. You cannot access the private members outside of the class. So just tell me, these statements are clear? We'll see with the example also, definitely. But right now, the examples, statements are clear. Okay, good. Good. So this is by default. Now come to some more thing. If you declare any class like this, so if I now ask that what is the access modifier or accessibility of this class, so can you tell me that now? We are not mentioning any accessibility over here. Then it is now my class has the access modifier, that is, yes, tell me, because I have already written over here. What will be the accessibility of this class? Default. Very good, Meng. Good, Justin. Within the same package? Sure, within the same package, and by default it is default. Good, Hinduja. Now, if I write there public, so now this is this will have the accessibility everywhere. Means anyone can access this class. Fine. Now the point. With the class definition or with the class that you write, note, this is important. The outer class, because there is a concept of the inner class and nested classes also, that's why I'm writing outer class. The outer class cannot be private and protected. Got it? You cannot define any outer class as private and protected. So if I write private and if I compile it, just look at the compilation, then it says the modifier private not allowed here. Okay, and the protected, let's see one more time, that is protected. Can we apply the protected here? So we cannot apply the modifier protector also with the outer class. Can we apply the public? And we have seen in the very first session, yes, we can create a class as public. And I told you one concept related to the public class name is if you declare any class as public, then source file or your source code name, file name must be same as the class name. If you have remember that point, then okay. So I hope this is clear to all of you. This is the accessibility: public, protected, default, and private. And this is from top to bottom, it is in decreasing order. And one more time, I'm telling you, remember these points, because if you will forget it, then you will not able to override a method. For overriding, it is important. Okay. And for creation of the packages and put the classes into the packages is also important. Now, let's see. Now tell me one more question to all of you. Is it required to create main method into every class definition? Is it required, or is it mandatory that main should be in every class definition? No? Good. So now I'm going to create a new class definition. I'm writing the same, I'm writing the class definition in the same source file. So don't be confused. So after finishing of this class definition, I'm writing new class definition. That is my class. The first class name was the my class. I'm writing the test. And here, I'm going to create a method that is void show. Show the result or show something. And here I will mention only one statement to see the accessibility. System.out.println. Okay. And I will write I am show from test class, so that we will get the message accordingly that this method is coming from the test class. One more method I'm going to create that will have the public void display method. And it will have one I am display from test class. So I have created one method with the name of show that has the default accessibility. I have created one method with the public accessibility. Let's call these methods into the my class. So first of all, I'll create the test object. OB is equal new test. Okay. After that, I will write OB.show. And I'm going to call OB.display. Fine. So will it be execute or will get any error? Meng, just tell me. We will get any error, or this is fine? This code is fine? Justin and Induja, tell me. Fine. Why? Because this is this method having the default accessibility, and default accessibility can be accessed within the same package. And since we are creating the classes into the same package, so we can call this method. Means this method will be accessible over here because my class and test belongs to the same package. Display having accessibility public, so it will access. There will be no problem. Let's compile and execute it. I'm show from the test and I'm display from the test. Now make this as private. After that, since this is the private and private cannot be accessed outside of the class, so it will show definitely error. Fine. I hope this accessibility is clear. And if I make this as protected, then let's see, compile, good, and when executed, access. Because protected can be accessed within same package, and if you want to access outside of the package, then through child. Now tell me, this statement is now clear to all of you. That how to maintain the accessibility of any member of the class, within the class, outer of the class, and within same package. So by applying these things, you can restrict any member. Visible screen, I'm getting a message that the screen is just tell me, is it visible, Justin? Okay. Hello. Is still not coming my voice? Okay, fine. So now, Meng, Hinduja, and Justin, just tell me these concepts. I hope these concept is now much more clear. If you know the modifiers earlier, then it is fine. If you have any doubt to this topic currently, if you have any doubt, then you can ask me. No doubts? Okay. Thank you, Meng. So, I'll bind this session today for here, and tomorrow we will start the session from the next topic, that is inheritance, because inheritance is a fresh topic, and when we will learn the inheritance, then we will move to the method overriding. So these two topics covers in the same day, so that will be fine. And related assignment, some questions, maybe you are practicing some questions, and you can find those questions from the websites. If you are following any book, or you can follow any website, so you can get it. If you are a user of Android mobile phone, then you can download one app that is called javap. This is okay. If you use Android phone, then this is the Java Provis application. Hello. Still, Induja, you can't hear me? Okay, Meng, just let me check. Okay, hello. Yes, now it is better. Yes. Okay, good. So one app is on the Play Store. If you use, yes, this is the app name I am mentioning over here. That is called Java Prowess. You can search on the App Store, Play Store. This is for the Android application, the Android mobile devices. So you can download and you can use it. There are so many examples you will find this that has been already solved, but I will say that before if you before going to see the solution, first of all solve yourself, and if you stuck somewhere, then you can see the um, solutions. So and you can find tutorials also. So this is the app you can find, Java Provis. Now so I will bind up here. Tomorrow when we will start the session, then first of all, if you have any doubt, then we'll discuss. After that, we'll discuss the next topic. Okay, so thank you so much for joining this session. See you tomorrow. Bye bye.